multi-class data set. If you look at this data set, there are 10 classes in the label target variable 0 to 9, but we converted this data set into binary class by converting the target variable into fives and not fives, right? So to understand the classification concept and the metrics and all the theory around it, now we are going to solve the original problem, the multi-class classification problem. So if you look at this data set, the labels are like all the labels are there, and I have taken the same labels whatever is given in the data set. I have taken those labels as y variable instead of converting them into um, binary class. Okay, and I am going to build a model. So let me show you the code first, and then we'll go into theory. So I have taken the same data set, but I did not convert, did not apply anything on the target label, and took that as y variable, and took all the input variables as x, and then using train test split, I splitted data. If you remember, when I said what is going to do the train test split, when I say test percentage is 20%, right? 0.2 means 20%. What is it going to do? How is it going to split the data?
Stratified test. Stratified.
Stratified, right? Stratified means from zero class it will take 20% into test set from one class, right? So y variable is the stratifying column here. Sometimes, right, when you want to split a regression data set using this method, right, you need to specify the stratifying column, right? Whatever the stratifying column has the y kind of a thing. Okay, you should take now that you should not be calling it as x and y, but you should be splitting the data into the stratifying column and the other data, and then pass it to the train test split. That way, what will happen? Based on the stratifying column, all the 0 records it will take, 20% it will put it into test set. 1 records, 20% into test set. 2 records. So that way, the train set and test set both are going to be balanced. Both are going to be um, um, distributionally similar. Okay, distributionally similar. Okay, so distributional differences will not be there. So the whatever the understanding we made on the train set is going to simulate and explain whether it is going to work well on the test set or not. Okay, so that is stratified sampling's importance, and train test split will do that. And now I applied standard scaling. I called fit transform on the X train, and then I used a SGD classifier and fitted the model. Till here nothing changed, right? Whether it is multi-class classification or binary class classification, nothing changed. But internally, the things are a bit different. Okay? When you look into the internals of the algorithm, it's going to be a bit different, especially when there are when there are algorithms which cannot handle huge volumes of data, the approach is going to be different. When scikit-learn is trying to solve a multi-class classification problem, and if the algorithm cannot handle huge volumes of data, the approach is different. When the algorithm can handle huge volumes of data, the approach is different. When the algorithm can handle huge volumes of data, then it uses one versus all algorithm behind the scenes. Okay. When the algorithm cannot handle huge volumes of data, it uses one versus one algorithm. Okay, we'll understand what those algorithms are. Okay, so when you are implementing, there is no difference. When you are implementing a model, right? When you are writing code and trying to make the model predict. See this, I have taken one record from the data and predicted. Let me try to run this and show. I think I should take a look. While writing code, there is no difference, but in the behind the scenes, there is a much difference there, and we need to understand it. Okay. We need to understand it. Why is it taking that much time? Shouldn't take. Shouldn't be taking that much time. Shouldn't be taking that much time. Let's wait for 1 more minute and then no, I'll restart the kernel. Okay, we restart the kernel. Why is it taking this much time? Okay, let it run. Okay, we trained the model, right? We said fit and it got trained, and then we made predictions on one record here, and then we are doing predict proba and decision function also. Right? So this is all same, whether it is a binary class classification or multi-class classification. Building a model is same. Right? Error matrix also same, but it is going to be a bit more confusing matrix. See the confusion matrix. I took the trained data and predicted and used the predicted values, y train and the actual values and the predicted values, and passed into confusion matrix. And confusion matrix is a bit big, right? Grigar asked a question on this, right? When the multi-class classification is on the multi-class classification, the confusion matrix is going to be more confusing. So when we understood the confusion matrix on a binary class, right, it is going to be easy here. So anyway, I'm going to explain this in a moment, right? So with this diagram, right, you can understand it better. Okay, so this is how we actually do build a multi-class classification model. So any questions so far? I'll explain the uh, confusion matrix, but beyond, before that, right? Any questions? How to analyze error? How to see whether there is problem with the model or not? Which class is identified correctly? Which class not? I'll explain in a moment. But related to model building activity and predictions, any questions? Only 4 joined today. That's okay. That's okay. Let's see. Okay. So no questions. Good. So let me move back to the slide here and let us try to understand how exactly the multi-class classification is happening. On a binary class classification, the algorithm is trying to do a decision boundary between two classes, right? Similarly, on a multi-class classification also it will try to do decision boundaries like this. There are triangles, there are circles, and there are rectangles. The algorithm will try to do a decision boundary like this. Multi-class classification can distinguish between more than two classes. In this example, it is distinguishing circles, triangles, and rectangles. Based on the x value, it will actually, based on the x value, x value and y value, it will find out the decision boundaries. And when a new record comes in, it takes the x value and distinguishes, or tries to find out in which region the record falls into. Okay. So by default, some algorithms such as random forest and naive Bayes can handle multi-class classification. This is a capability of the algorithm. Some algorithms can handle multi-class classification, but some algorithms like SVM and linear classifiers, logistic regression and SGD classifier and SVM, support vector machine. These kinds of algorithms cannot handle multi-class classification. In that case, if the algorithm can handle huge volumes of data, SGD classifier can handle huge volumes of data, it is going to use one versus all algorithm, right? Algorithm on top of algorithm, okay? And SVM cannot handle huge volumes of data. We'll see how and why SVM cannot handle huge volumes of data in the coming week, maybe by weekend or maybe next week. And one versus one is the algorithm it's going to use. When the algorithm, so on top of SGD classifier or support vector machine, there will be another algorithm used to do a multi-class classification. Okay, how? I'll explain in a moment. When we use multi-class incapable algorithm, scikit-learn detects and most of the times it applies one versus all automatically, right? When the multi-class classification problem is there and you are trying to use an algorithm like maybe SVM or SGD classifier, the scikit-learn by default identifies that the algorithm cannot handle multi-class classification and it uses either one of these, but most of the times it uses one versus all. Okay. For SVM, it uses one versus one because it cannot handle huge volumes of data. Got it? So implementation point of view, you will not have any. What happened? Oh, okay. Okay, it's already numpy. Cannot reshape. Okay, sorry. See that? Previously, it got I got an error, right? I got an error, right? Why did I got it? And when I reshaped it, why did I the error went off? Can somebody tell me? Should I reproduce the error?
Yeah, yes, please.
Okay, let me reproduce the error. So the point I am trying to make here is, right, whether you use SVM or SGD classifier or random forest or naive Bayes, scikit-learn will not have any difference. You can actually simply fit and transform and whatever, right? Predict and whatever, right? You will not have any difficulty there. But behind the scenes, many things are happening. You need to understand interview purposes as well as the theory you need to understand, right? So how it is happening, you need to understand. So I will explain that in a moment, but let me try to reproduce the error. I think if I restart, right, that training will take more time. Let me see. Let me see here. What? Did I restart? Digitex train. Did I restart the kernel or what? Yeah, I think I restarted the kernel. Not have done that. Take a little bit of time, right? We'll go back to theory and come back here. Okay. So So how is it? How is the scikit-learn algorithm? What is this one versus all algorithm and how it works? We'll try to understand that. Okay. So you have in this data set we have three classes. So the one versus all algorithm will convert the data set like this: triangle, other, triangle, other, triangle, other. See this? So it is taking triangle as the class one, the other classes, right? Whether it is circular, rectangle, it is making all of them as other. Did we do the same thing in fives and not fives? Did we do the same thing or anything different?
Same things.
Same thing, right? So I created the data set to explain this. Okay. Internally, when you are doing a multi-class classification with algorithms incapable of doing multi-class classification, they'll convert the data like this. It will actually convert zeros and other non-zeros, a data set, and build a model. Ones and non-ones, build a model. Twos and non-twos, and build a model. 10 models it will build. When a new record comes in, it will pass the record to 10 models and calculate the probabilities. Right? First model will give you probability of becoming 0. Second model will give you probability of becoming that record belonging to 1. Third model will give you probability of that record belonging to 2. Fourth will give you probability of record belonging to 4. Like that, 10 probabilities you get. If you look at this predict proba, see these are are the decision function. It is giving you 10 scores. All those 10 models will give you 10 scores. One versus all algorithm is that. Got it? Got it? Any questions?
So by default, scikit-learn apply that one versus all?
Yeah. Yeah.
Okay, okay.
So it knows to which algorithm it should be applying one versus all, and to which it need to apply one versus one. See, scikit-learn is implemented by a team, right? They know they are the ones who are implementing the algorithm, and they are the ones who are actually implementing one versus one all or one versus all also. And they must be knowing it. So there must be a marker interface somewhere in the class which actually denotes that the algorithm is capable of doing one versus one or capable of doing one versus one.
Okay.
Got it?
Yeah.
So intentionally we have actually done it. The binary class classification. Right? This data set preparation, right? Not files and not files. I actually intentionally did it because in multi-class classification that's how it happens. When you use some models like these, some algorithms like these. Okay, it's still running. Once it runs, right, I'll show the error and you can answer the question. So any questions here? How the multi-class classification one versus all algorithm is working?
Sir, you mentioned that internally it will select based on the algorithm like SGD or maybe something else, right? So that point is not clear. So we understand that if the data is huge and if they can use SGD, they can definitely go for a binary classification for each of the class. But how that selection of SGD versus non-SGD? Give me an example where non-SGD they can make use of internally, sir.
I'll explain that in a moment, but I did not get your question clearly. See this here. If you look at this code, multi-class classification code, when we wrote the code, what we did, I just used SGD classifier and then fitted and then predicted, right?
Right, right.
So did I do all this stuff, whatever I am doing here,
No,
like
you
this?
did not give.
So that is what is internally the algorithm is doing. The
Okay.
scikit-learn is actually doing this all activity for us.
Okay, okay.
So in binary class classification, I manually did it to
Correct.
show you,
Correct.
an example and then to understand the theory and all that, right? But
Right.
when it is multi-class or binary class, it doesn't matter. For the algorithm, it doesn't matter. For the scikit-learn, it doesn't matter because it knows how to split it and how to transform the target variable and build a model and all that. Got it?
Okay, sir. Sure.
It's a wrapper, right? The scikit-learn is a wrapper, and it is making our life easy.
Okay.
In doing multi. So if it is not doing all this stuff right, we would have to convert our data into zeros and non-zeros, ones and non-ones, twos and non-twos. Every time we need to build a model, and when a record comes in, we need to pass the record into 10 models and get the probabilities and see which one is high. You need to predict that that class record belongs to that particular class. We would have to do that if scikit-learn was not doing it. Scikit-learn is actually doing it for us, so it is good. Life is easy. We're just saying fit and then predict. Right?
Yes, sir.
Right? Yeah. So here, see this here. Right? When I actually took the record and then asked it to predict, it threw an error. So let me show you the error. So this is the error. What is it saying? Expected 2D array and got 1D array. Why is it expecting 2D array while predicting? So while training, what we did here? What is this? Is that a two-dimensional array or one-dimensional array? That digit X train. Huh?
2D, sir.
2D array, right?
Yeah.
So we
Multiple
are
X values are there.
yeah. When we took from the numpy array one index, it actually gives you one-dimensional array. When I try to pass one-dimensional array to predict, right, it is unable to understand the structure. So you need to convert this, If 1 comma 7 84. How it will work? The record belongs to 3. Yeah.
Sir, you cannot put whatever shape the other column value, right? Because it depends on the number of x's, like x1, x2, x3, like that, isn't it?
We can say -1 there. Got it?
Okay.
Is that what your question or something else?
No, basically in the reshape, when we want to specify the columns, the column should be the number of x variables.
Yeah.
It should be equal to number of x variables, isn't it?
Yeah. Yeah. So in this we have 784 x's and 1 y. Even if you don't know, we can just put 1 comma -1 that automatically converts, and we can pass it and then it predicts, because each record will, we actually pass the records only, right? So
Okay.
so that's about how to build a model. But if you come here, this is how it is actually doing it, right? When new record comes in, it passes it to the all classifiers, and then sees which probability is high. So if you look at the code here, I actually tried to simulate that also a little bit, right? So predict proba is going to give you 10 probabilities, right? Out of these 10 probabilities, which one is high? This one, right?
This one.
9.999 into 10 to the power of -1, right? -0, sorry, 1 0 0 0 1. I don't know. -1, I think it is. It is zero point 0.9, so 90% accuracy, 99% probability that 1 2 3, sorry, 0 1 2 3 classes. Okay, how do you know that is the order? How do you know that is the order? right? Classes underscore is an attribute in the algorithm that gives you the order in which the classes were considered. So this decision score belongs to 0, this decision score belongs to 1, this decision score belongs to 2 class, like that. Similarly, this probability belongs to 0, this probability belongs to 1, right? This probability belongs to 2, this probability belongs to 3, like that. Okay, there is in NumPy there is a method called as argmax. Okay, argmax will give you the index of the index of an array where the value is high, index of an array where the value is high. If you do argmax here, right, what will you get on this array? If you do argmax, what will you get? Argmax gives you index of
9.99949.
index, it gives
Yeah.
index
Of
3
that
it
value.
gives 3 it gives. Yeah, you're good, you're almost there, right? You know, it gives you the index only, it is not going to give you the value. It actually looks at the values, and whichever value is high, that index it returns. See, when I did argmax, it gave me 3. That's how it actually predicts. The algorithm, when you say predict, right, it takes the predict proba or decision function, right? When you take yeah, generally it takes decision function only, because some algorithms will not give probabilities. Especially last function is hinge last, it will not give the probabilities. So it's going to take the decision function, and then looks at argmax of the decision function's output, and takes the whatever the index, and then predicts, right, that the record belongs to 3. Okay, this is how internally it is predicting. We need to understand this structure, this mechanism, because in deep learning it's going to be useful. Okay, I'm going to mention this again in deep learning. Okay, any questions so far?
Yes, sir. So this decision function gives, for example, in our case, the current case, I think we have 3 classes, right? Is it?
10 classes here.
No, not. Oh, okay. In the data set, we have 10 classes?
Yeah. This is a digit recognized data set only.
Okay.
I did not took this triangle rectangle one. This is just for
Okay.
example. If
Oh,
I
I
put
thought
10
you.
classes here, right, it's going to be clumsy to show.
Okay. Sure. I thought you took the triangle
No.
rectangle. Okay, got it.
10 class, sorry. Yeah, 10 classes. I would have explained that. 10 classes are there. I am going to use the same data set for next couple of classes, because understanding concepts is more important than taking a new data set and trying to struggle with it.
So in the
Yeah.
decision function, these are all the values which are actually showing that how far the value is from the decision boundary, right?
How far is the data point from the decision boundary?
Decision boundary. So there could be negative or positive values. So when we say argmax, so there could be a negative value also, right? Which is actually a predicted one.
Generally, this value is going to be positive only. If you look at decision function or a classification thing, or the the distance on the upper side is going to be positive, lower side is going to be negative. Right? For the record, it will be to which it belongs, right? Decision score is going to be positive only.
Is it always? I don't think, right?
It will be a positive only. If you look at this example, you will understand. See this here? When you take an equation and try to substitute the values of the positive records, you will always get a value greater than 0. Like that, so this decision boundary, below it is all going to be negative, above is all going to be positive, like that it is. Until and unless the decision score, or the equation's outcome is greater than or equal to 0, you will not get a probability greater than 0.5, right? Got it?
Okay, so in multi-class classifier, so there will be the decision score function will give only one positive value.
One positive value and rest negative, mostly.
Okay.
Yeah, one positive and rest negative. Because the record below should belong to that one, right? Sometimes it may give, a little zero, close to zero value also. See this here? This is minus 11, right? Sometimes it may come even closer. And maybe, point zero point something also can come. But argmax will actually make sure that, sometimes what happens is the probability of a particular class is going to be 0.7, and if you say 0.7, right, total probability should be 1, right? When you sum all these probabilities, it should be 1. So that way this 0.3 will be distributed among the other classes. If somebody wrote 5 and 8 in a confusing manner, and we are trying to build a model with that data, that sometimes it may be the model may be a little, here and there, and it may give you probabilities or the decision scores which are close. But ultimately it's going to take argmax only. Got it? Theoretically.
Sir, actually, the distance or the decision function outcome is not much of use to really take a final decision, but the probability will be the real useful thing.
Either one can be
decision.
Either one can be used. Either probability or the decision function, decision score you can use. Because if you use SVM algorithm, support vector machine, you need to explicitly say that the probability is equal to 2. Predict proba, some parameter is there. Predict proba is equal to 2. Then only it will give probabilities. But by default, all the algorithms will give you decision scores.
Okay.
Either one can be used.
Okay. So in that case, when you look at Shashiram's question, so it will always see for a particular given class, the highest probability case there can be definitely negative distance. So it's not that always it will be positive only, sir.
Why negative? How will you get negative? Negative distance.
See, can you open the slide, sir?
Yeah.
Yeah. So here, if the probability of a particular new digit or new record that comes in, it's if the probability can be high in the red area here, possibly its probability can be high. That particular record, the new record, what we are trying to predict, and if you bring in some other record, its probability can be.
So when you say all records are falling in all the all the probabilities, 10 probabilities or 10 decision scores are falling in this area, then the algorithm did not understood properly. That will not happen. Generally, it will try to put the total probability should be 1. When you look at decision score, right, you cannot specifically say. But when you look at probability, right, total probability of 10 classes should be equal to 1. When you sum all the probabilities, right, it should be equal to 1. When you say it should be equal to 1, right, if you get all the probabilities very small, then only you will get all the decision scores negative. And one of the negative score is going to be high. Got it? Analogy?
For example, if we take this particular example, the binary classifier, here if you want to predict zeros, let's say the incoming record is of 0 label. So here the value will be less than 0, right? Negative value.
There, you will have two models you built. One model, in a binary class problem, you will not have that generally. But if you theoretically think about it, right, you would have built two models, one for 1 and another for 0. The one model will give you less probability, 0 model will give you high probability, or one model will have a negative decision score and 0 model will have a positive decision score, something like that. Got it?
little bit now.
Yeah. Yeah. One, at least one should be greater than 0. But sometimes you may get more than one also greater than 0. But out of those greater than zeros, there will be one biggest value. 99% of the times you will have only one greater than 0, the decision score.
I do not think so, sir. The reason is in case of binary problem, we'll get single distance or single probability.
Even in binary class classification, you will get two probabilities, two distances.
No, for one record which we are trying to predict, how we'll get two distances?
Two probabilities it will give. You know, I have shown you that. Algorithm works like
actually
that.
builds two models, right?
No, it will not build two models, but it will actually derive the other probability. Based on, it will actually build a model for one and one only, but it will actually derive probability for other. See this here? So decision score it is giving only one, but you know, probabilities it will give two. Yeah, that's a mistake only. Yeah. See this probabilities it is giving two. Algorithm will give you two. It is actually using, you know, building model for one only, but deriving the other probability by saying 1 minus that probability. Got it?
So in binary, yes, but in okay. So I think Giri, you want to clarify first? It's a mix of
Yeah.
two different.
Yeah. What I'm saying is, for a moment, let's forget about the probability. What I'm saying is, depending on the number of classes, if it is a binary class, we'll have one, and there is, because there's only one line with respect to which we need to measure the distance of a new record.
Yes,
There will be one value, and that particular distance can be negative or positive.
Yeah. If it is negative, what? Positive, what?
Yeah. If the new record comes in, if the
No. My question is, if the decision score is negative, the record belongs to which class, and positive, the record belongs to which class?
if it is negative, it's a 0 for the binary case.
Positive,
It's
it is 1, right?
Yeah.
So same thing in the multi-class also it happens the same way.
True, that is true. No. The reason why I'm making this statement is you mentioned that most likely it will be positive only. That's what you mentioned, sir.
No, it is positive only. That's what I'm saying. 99% of the times, I'm saying only one positive value. It is positive only always. See, if the record belongs to 5, if the model predicted it correctly, the decision score for the 5 class is going to be positive only. Shashiram made a statement that it can be negative also. That is wrong.
No, why every record has to be 5? It need not be 5, right? It can be not 5 also, isn't it?
No, I was talking about multi-class and binary mixed up. You are talking about only binary class. In a binary class classification problem, if the record belongs to 5, the decision score is going to be positive. If the record belongs to not 5, the decision score is going to be negative. Do you agree with the statement?
Yes, sir. I agree.
In a multi-class setup also, the same thing will happen. If the record belongs to 1, the decision score for one class is going to be positive. Rest of all classes is going to be negative. The record, if the record belongs to 6, right, the decision score for 6 is going to be positive. Rest of all classes is going to be negative. What Seshiram made was, even for the class belonging to 6, there can be a negative decision score. That is not going to happen. The example is this one only. Got it? No? Yes?
Yeah, that means like multi-classification divided into the number of models as a binary classification, right? So 0 ones.
Yeah, zero ones. Yes, sir. That's where the key is, right? If you understand this, right, that is also understood. Did my analogy explain the question, or still confused?
Confusion is there, sir, actually.
Why confusion? Let me know. If you look at these scores, right? These scores, It is a binary class classification problem, right? 5s are not 5s. Will there be a record, for which you will get a negative score? The record belongs to 5. If the record belongs to 5, will you get a decision score negative?
Okay, before I answer that, earlier in the multi-class, you are using for a new record, you are getting the decision function values, sir. But here you did not. Whatever you are showing now for binary, you did not use that. So there is a difference in that comparison.
No, new function. I didn't get the question.
No, can you please go show us the multi-class?
Yeah, this is multi-class.
Yeah. So here you took what is the input here? It's in some new record, isn't it?
Yeah, some one record I passed.
Yeah, exactly. So you took a new record. For that new record, we are trying to measure the distances for each of the possible class. That is 10 classes. Is that correct?
Yeah.
For a given new record.
Yes, sir.
So that is why. So here for some classes it's a very small negative value. For some classes it's very some positive value, and some are very high negative values. That's how it's distributed. So our understanding, at least my understanding, is it is saying that minus 11 is there, right? Correct. That is the smallest distance. Ignoring that whether it's negative or positive, that's the smallest distance. So this record is the most likely fall into that particular class corresponding to
No,
minus
if you
11
see, there is a positive value,
understanding.
right? There is a positive value here. There is a positive value, sir.
I see that.
So why are you going to minus 11 when there is a bigger number? This is the biggest
11,
number. This is second biggest, right?
No.
343 is the biggest number out of all these 10, and the second biggest is minus 11. Do you agree?
Yeah, I agree.
It's a kind of residual, sir. If it is a residual kind of stuff, the distance is less. In the negative way, but distance is less. 11 is less than.
So why are you falling behind 11? I am still not able to understand.
No, if you take
my question,
distance,
go ahead.
For distance, we need to get the absolute value of the.
No, absolute value. It is not absolute value. It is the highest distance. That's it. Even if you take absolute value, you will get this as the biggest distance, right? Then the record belongs to 0, 1, 2, 3 only. Let me go back to binary class and let me explain this, and then you think about that. Okay, whatever we are doing in a binary class, we are magnifying it in multi-class. Okay, we just magnified this. We actually did multiple models of this binary class in multi-class classification. So if you understand binary class, right, you will understand multi-class also. If you look at this, given record, right, I have taken the whole data and tried to predict it. For a given record, there will be a negative value or a positive value. Do you agree? The decision score?
Yes, sir.
Huh?
Yes.
If the value is positive, I will say the record belongs to 1. If the value is negative, the record belongs to 0.
That is correct.
Right? Here 1 means 5 class, 0 means not 5 class, right?
Correct.
Right? So now, if you replicate the same thing, right? If you replicate, right? 5s and not 5s I have taken, right? 0s and not 0s, 1s and not 1s, 2s and not 1, not 2s. Like that, I created 10 data sets. I have taken one data set and created 10 out of it. Do you understand?
Yes, sir.
Right? Now I am building model. Right? 10 models I am building. In each model, I am going to pass the value, pass the record. Right? Pass the record to each model. When I pass record to each model, I may get a negative value or a positive value. 10 values I will get. Do you agree? For one record, I will get 10 values. Do you agree?
Yes.
Right? So I passed the 5 record. Right? I know that record belongs to 5. I passed it to first model. First model is 0 or not 0. It gives you a negative value. Right? Because the record doesn't belong to 5. Right? You pass the same record to one, right? One model. That also gives you negative. Two model also gives negative. Three model also gives negative. Four model also gives, five model gives you positive because the model understands it. If it is not understanding, right, out of all those 10 models, one value will be positive at least. You are saying is that, there may be a chance that any model out of all those models may not give a positive value. It may be a negative value. That's what you are saying, right?
Yeah.
If the model is unable to understand properly, then it might happen. Very rare it is. Right? For some records it may happen, but it is very rare. Okay, there will be a positive value in the decision scores.
So it means that there will be only one positive value then? Correct?
Yes. Maybe more than one can also be there. If the probability, right, there is a relationship between probability and decision score. If the probability is like 0.6 or 0.55, if the probability is 0.9, right, definitely the decision score is going to be high. If you look at this diagram, if the record is very close to the line or on the line, right, then the decision score is going to be very small, maybe 0.05 or something like that. And probability is also going to be like, 0.6 or 0.5, 0.51 or something like that. Right? Got it? On the line records are going to have decision score small and probabilities are also close to 0.5. The far away records will have decision scores very high and the probabilities are going to be probabilities are also going to be close to 0.9. Got it? Got it?
Yeah.
If this one record is actually falling here, right? If the one record is falling on this side, what will happen? To zero class it will be positive. So for the one class it's going to be negative. Got it? In a multi-class classification, right? If you look at this multi-class classification, if the star falls here, it is going to be classified as triangle. So in the triangle class, you will have positive value. Got it? For the triangle class, the decision function is going to give you positive value, even though the record belongs to star. That's a wrong prediction. The decision boundary is wrong, but the one value is going to be positive because the distance between this class and the record is going to be, right, positive, right? Got it? Got it?
Yes, sir.
If it is on the boundary, right, the values are going to be a little here and there. Maybe a positive but close to zero and positive a big number like that. Got it?
Yeah. So in that case, there should be only one positive value for
Yes, sir.
if it
Any
falls
given
to-
record. Any
Yeah.
given record, decision score, one positive value will be there.
Sure.
Because of the record falling into one side. Either side it should fall. Sometimes it may fall on the line. That's when you actually get positive values, but very close to zero and like that. Okay. He doesn't know whether it belongs to this class or that class, so it's going to give you a little bit of positive value here and there. It may be negative value very close to zero also. Okay, positive value very close to zero for one class and negative value very close to zero another class. Because the line above the line, the value is going to be greater than or equal to zero. Below the line, the value is going to be less than zero. So, using this kind of math only, it is going to find the distance also. So that way, the value is going to be, the decision function value is going to be positive for one record, one class, sorry, for one class. Okay, answered or still having confusion?
Yeah, it's clear for me, sir.
Sesigar,
Yes, sir.
it is
We'll
based
go.
on it is based on the line. It is based on the equation. So definitely the record should fall on this side or that side. Sometimes it may fall on the line. That's when you get a positive value and negative value which are very close to zero. Okay, exactly on the line, right? Zero you will get. Okay. Got it? I think I made one wrong statement. Sometimes you may get a positive value which may be a little less, but it will not happen. Because of the line, it may be a 0 or a positive value or negative value. The record should fall on either side or on the line. Right? Even on the line, if it is exactly on the line, it's going to be 0. Little bit higher or little bit lower, it's going to be very close to positive and negative. Ultimately, when you do argmax, right, you will get that index. That's where the prediction is going to, that's how the prediction is going to be made. Okay. Moving on. Any questions? I think it's a good discussion, right? I may have confused a little bit, but ultimately the clarity came, and the decision boundary, like the decision boundary is the basis. We need to understand that. Okay. Okay, let me move on. So 1 versus 1, right? 1 versus all algorithm we have seen, right? When new record comes in, it passes the record to all the classifiers and finds out the probabilities or the decision scores, and it decides. And 1 versus 1, right? 1 versus 1 algorithm works like this. 1 versus 1 algorithm is used when the algorithm is incapable of handling huge volume data, huge volumes of data. Okay. So in our data set, right, in our digit recognized data set, we have 42,000 records, right? But on the train set, we have around 33,000 records, right? On train set, we have around 33,000 records. If you try to do a 1 versus all algorithm, right, you are going to build 10 different data sets, right? Using the same data set, you are going to build 10 different data sets. First data set will have label as 0 or not 0. Second data set will have label as 1 or not 1. Third data set will have a label as 2 or not 2. Like that, you are going to build 10 data sets. On each data set, we will have 33,600 records. Do you agree? When we do 1 versus all, on each data set, the algorithm trying to build models with, you will have 33,600 records. Suppose that your algorithm cannot handle 33,600 records. Why it cannot handle? If you take linear regression algorithm, it uses that normal equation, and it cannot handle huge volumes of data because it actually takes everything into RAM and tries to do manipulation and all that, right? There are algorithms which cannot handle huge volumes of data, 33,600 records, suppose that, right? Then what you can do is, you can take the records belonging to 0 and the record belonging to 1. Then what happens? What is the size of the data set? If the record belonging to 0 are 3,500 and record belonging to 1 are 3,500, you are trying to build a data set with only records belonging to 0 and only records belonging to 1. How much is the data set then? Size?
Smaller than the total.
7,000, right? 7,000, right? Around 7,000 or maybe 8,000, right? Smaller, right? Got it? Right? Algorithm, right? Now the suppose that SVM you took, support vector machine, and it's going to build a model with 8,000 records. Instead of doing 33,000 records, it's going to build 8,000 records model. That is the first model, right? 0 versus 1 it built. Again, it will try to take the records belonging to 0 and the record belonging to 2. Again, around 8,000 records, and it's going to build another model. 0 and 3, 0 and 4, 0 and 5, like that, for 0 record itself, it's going to build 9 models. Got it? 9 data sets, it's built out of the existing data set, and built using those 9 data sets, it built a model. Okay. Okay. Got it? Got it? Can I move on? Now you will get, for 0 itself, you will get 10 probabilities, right? For 0 class itself, you will get 10 probabilities. Okay, if one of the, in all the probabilities, right, if all the models, right, 0 versus 1, 0 versus 2, 0 versus 3, 0 versus 4, 0 versus, all probabilities are greater than 0.5, is the record belongs to 0? Should I take an example here and explain? See this diagram.
Can you come up with the statement again, sir?
No, let me show you this diagram and explain. Okay, so in this data set, right, we have 1, 2, 3, 4, around 12 records are there. Okay, there are triangles, rectangles, and circles. Okay, 12 records are there. In 1 versus 1 algorithm, what it will do is, it will take triangle versus circle and triangle versus rectangle. Two models it is building for triangle only. And then built a model, right? And then took a record and tried to predict for this record. Okay, took the first record and tried to predict. First model gave a probability greater than 0.5 and second model also gave a probability greater than 0.5. Will the record belong to triangle?
Yeah.
Yes.
Yes, right?
Yeah.
So this is also binary class classification only. What we are doing here, because algorithm is unable to handle huge volumes of data, we are reducing the data set size. Got it? Got it? Reducing the data set size, but for each class we are building multiple models. Okay. There for each class, in 1 versus all, we built for each class one model we built. Do you agree? 0 versus all, 1 versus all, 2 versus all, 3 versus all. We built 10 models only. Okay. But here, right? If you take triangle example only, we built 3 models only. Total 3 models we built. Triangle versus all, circle versus all, rectangle versus all. But here, for triangle we are building 2 models. For circle we will build 2 models, and rectangle we will build 2 models. Got it? 6 models we need to build. How are we getting 6 models? We derived 6 data sets out of the existing data set and then built a model. Okay. So it is going to build n into n minus 1 by 2 number of models, where n is the distinct classes. So if you see this here, 3 into 3 minus 1 by 2, 3 models it's going to build. Why 3? If you build triangle versus circle, no need to build circle versus triangle. If you build rectangle versus triangle, no need to build rectangle versus triangle. If you build, circle versus triangle, no need to build triangle versus circle. Out of all 6, right, you can build 3 and use use it like this. Probability of rectangle versus triangle is equal to 1 minus probability of triangle versus rectangle. Right? Probability of rectangle versus circle is equal to 1 minus probability of circle versus rectangle. You can take average, right? This probability and this probability, you take the average. If it is, if it is 0.9 and 0.9, you will get 0.9. That means the record belongs to triangle, like that. Got it? This is how the 1 versus 1 algorithm works. Got it? Any questions? Confused a little bit?
Yes, sir. The reverse way, like, the probability of triangle versus circle is P1, and the probability of circle versus triangle, the reverse way is 1 minus P1. How will
Yes.
that be? It should be same, right?
No, one minus, see, that's the point. When I am building triangle versus circle, right, I am giving triangle 1 and circle 0. While converting y, right, I will be giving triangle 1 and circle 0. I am building a model. Okay. Right. If I try to predict now, if it gives a probability greater than 0, that is saying the record belongs to triangle. Got it?
Yes.
Right?
That's right.
Yeah, if you want to flip it, right, you would have to flip the circle. You have to give 1 and triangle 0 and then build a model again. Instead of doing that, I'm actually taking 1 minus probability. See this here in the binary class. We have got two probabilities, right? This probability, the algorithm is going to find because the record belongs. The one probability it's going to find. 1 minus of this value is going to put here, right? If you have to flip, right, you have to flip the target variable and build a model. Instead of doing that, you can actually take 1 minus and then take the probability. If it is less than 0, right, if the value is close to, if the value is close to 0 on the one class, that means the probability on the 0 class is high, right? So 1 minus of this is that, right? Got it? I think you got it.
Yes, sir. Yes, no.
So that's how the 1 versus 1 algorithm is going to work. So it is going to actually take, the probabilities and, weight it. It's going to normalize it. So because when you sum all the probabilities, right, it should become 1. In any algorithm, when it is predicting probabilities, for all the classes, there will be different probabilities, but when you sum up all the probabilities, right, you should have 1. You should get 1. So to get that, right, it is going to normalize it. Right? You take triangle versus circle and triangle versus rectangle probability and divide it by all the probabilities, and triangle, probability versus probability of circle versus triangle plus probability of circle versus rectangle. If both are 0.9, it's anyway going to be 0.9 only, right? If both are 0.1, it's going to be 0.1 only, because if the record doesn't belong to that class, right, it's going to be less. If the record belongs to that class, it's going to be more. Okay, think about it a little bit and you will get it. Okay, I'll show you how exactly we can actually use 1 versus 1 and 1 versus all programmatically. Okay, see this here. We'll do the error analysis tomorrow. See this, there is 1 versus rest classifier. No need to use it. No need to use it. If you directly use SGD classifier, scikit-learn will take care of it. But you have the class. In some interviews, some people who are very enthusiastic will ask these questions. For interview purposes only, I explained 1 versus 1 and 1 versus all. Okay. So 1 versus rest, and it takes the algorithm as input and does whatever, right? So fit estimators, 10 estimators we have got, and 10 probabilities, 10 decision scores. 1 versus 1. 1 versus 1 classifier, and it takes the SGD classifier, right? And then it actually gives you 45 classifiers, 45 estimators. Why? N into n minus 1 by 2, right? For 0, it is going to build 9 classifiers. For 1, it is going to build 8 classifiers only. Why? For 1, it is going to build 8 classifiers only. Why?
0, 1 is already completed. So
0, 1 is already completed. You can take 1 minus of whatever that 0, 1, and you can take it as 1 versus 0. Okay, 1 versus 1, 1 versus 2, 1 versus 3, those things will be built. Again, for 2, it is going to build only 7. For 3, 6 only. For 5, 4, it's going to build, 5 only. Think about it. I am talking, whatever I am talking is all correct. Think about it a little bit and then, you'll get it. See this here, decision function. Oh, see this, this is actually giving positive values. One negative value and rest are positive values. I think this decision boundary came in such a way that the record is actually falling on a positive side for most of the classes, but out of all those, it will have the highest probability for the class which it belongs to. Okay, but one definitely positive value is going to be there. Okay, one positive value definitely it's going to be there. I think my statement was right. Previously I said that there may be positive value. When it is multi-class, my statement was right. When it is binary class, my statement was wrong. Okay, the record belongs to either the decision function value is going to be either negative or positive for a binary class classifier. But for multi-class, right, there can be more positive values like this. Okay.
So in this case, which the max positive number we need to consider?
Max positive only. See this here, if you take argmax, right, you will get this. See this 9.33, whatever is the maximum value. And the index of that value is going to be the prediction.
So is it possible to depict this on diagram kind of stuff? Take a point and or take one.
This is the diagram, sir. This is the diagram. I think in the diagram we have it. If you see the first diagram, right, see this, in this line, right, this line may be going like that, right? For the rectangle and for the triangle, you will have negative or positive. Wow, take this positive, right? The line is going like that, right? This line is going like that, right? But these two, it will have positive and this will have negative. Got it? Got it? For these two records, the line is going like that. This record is on the downer side and this record is also on the downer side. For these records, it will be positive, but this one also it's going to be positive. But this positive value is going to be less than compared to this positive. Got it?
Sir, more positive value means it's more far away, right?
Yeah, the farther the better. The decision, decision making. Farther the better. That's the right point.
Okay.
Closer ambiguous. This point is very important for SVM, support vector measurement, that actually solves that problem. This is a very good important point. If the point is close to the decision boundary, the decision made is ambiguous. It is not sure that the record belongs to perfectly not sure. The score is higher, the surety is more. Got it?
Yes, yes.
So we'll stop it here and start with the error